Alright, so today we're going to study something called arc length. It's a concept you should have studied in geometry, but today we're going to do it in radian form. We go back to the definition of a radian as the arc length divided by the radius of the circle. And if we have that, we can rewrite it to get any of those alone. So we're going to get arc length alone. Arc length is the S for some unknown reason. So mathematically, if we're going to rewrite this to get the S by itself, we need to not divide by R. So we're going to multiply both sides by R to cancel that off. And so the formula that we're going to use is arc length equals radius times theta. Theta is the angle measured in radians. Not in degrees. If it's in degrees, we have to convert. Okay? So, for example, problems like this. If a circle has a radius of 25.6 centimeters, find the intercepted arc by the central angle having each measure. Find the arc intercepted by the central angle having each measure. Here we go. So find the arc length. Find the arc, find the S. So S equals radius times angle measured in radians. Remember, if something isn't a fraction, you put a 1 underneath it. So we would have to do 25.60 times 7 pi, and then 8 times 1, so divided by 8. So I'm just going to do that on my calculator. I'm going to know what I need, and I'm going to type it in. So 25.60 times 7, where's the darn pi symbol? Oh, on a TI, it's over here at the exponent key. On a Casio, it's on the bottom row above that EXP key. So 25.60 times 7 pi equals, divided by 8, equals 70.37. Because of significant digits, that's why they left that 0 on there. We would only go to 37. 2 significant digits, so we would have 2 significant digits in our answer. Okay, it was centimeters, so centimeters. Okay, there's a variety of these, ranging from easy to difficult. This one, also easy. Arc length equals radius, which is 14, times angle in radians, 10. There's no degree symbol, so that is radians. So that's just 140. I didn't put units on the radius, so I don't know what units of measure we have here. So let's just say units. So what do you do if they give you a degrees? Well, we have to go back to the first skill we learned this chapter, which is if they give you in degrees, then you also need to multiply by the fraction that converts degrees to radians. So put the 180 on the bottom, put the pi on the top, and now you have an extra fraction in your formula that you didn't have before. So remember, these would be over 1, so we're going to have to do 12 times 10 times pi divided by 180, right? 1 times 1 times 1, or 180 is 180. So 12 times 10 times pi equals, divided by 180, 2.09. Again, because I think that's 2 significant figures, that's as far as we would go. But okay. What if they ask us to find a different variable than arc length? Find the measure of the radius of each circle. So find R. If they give us the angle and the arc length. So the arc length, remember, is the S, the angle is the theta. So if we're doing S equals R theta, we know 6 pi equals R times 2 pi over 3. Well, that's awful looking. Let's see what math we know. We could put a 1 underneath this and combine that to be R times 2 pi over 3. We can multiply both sides by 3, so we get rid of the dividing by 3. So 18 pi equals R times 2 pi. And since we're looking to get R by itself, we can divide the 2 and the pi. And when we do that, the pi's will cancel, and we just have to do 18 divided by 2, which is 9. So the radius must be 9 units. That was pretty bad because of the fraction, but if it were not a fraction, it would have been a lot simpler. It would have just been divide. Okay? Or what if they ask us to find the angle in radians, given an arc length and a radius? So remember, the formula is arc length equals radius times angle. So 15 equals 6 times theta. Oh, that's easier. So just divide by 6. Theta equals 2.5. The angle is 2.5 radians in size. Okay. Now what if they put them in words instead of just giving you the measurements? Okay. These latitude and longitude ones are crazy for people. So I'll do an example of that. Erie, Pennsylvania is due north of Columbia, South Carolina. Erie's latitude is 42 degrees north and Columbia's is 34 degrees north. Find the distance between the two cities if the radius of the Earth is 6,400 kilometers approximately. All right, so we need a picture. If we think about the Earth, and it's got an equator in the middle, right? The equator would be 0 for us, 0 radians, or 0 degrees. These are both north cities. So Columbia is 34 degrees north, so above the equator. As we normally look at globes, some people would debate the northern hemisphere slant there, and Erie, Pennsylvania is 42 degrees, so a little bit higher. Find the distance between the two cities. So find the distance. Remember, you would drive on the Earth's crust, not back here in the core of the Earth. The core of the Earth would be the central angle, and here's our radius, 6,400 kilometers. So we're looking for the part of the circumference. We're looking for the arc length. If we know that our radius is 6,400, and we're looking for our degrees. Well, how many degrees is this angle between the two cities? It's whatever the difference between 34 and 42 is, right? 42 subtract 34 equals 8. So that's an 8-degree angle. So 6,400 times 8 degrees. But I want to have that in radians, so I'm going to put in the converting fraction as well. So the degree symbols will cancel each other out. These would both have 1s on the bottom, remember, so I'm going to have to do 6,400 times 8 times pi, and then divide by 180. So 6,400 times 8 times pi, divide by 180. So 893 kilometers. 893.609 kilometers. The back of the book, if you look up answers, is only going to have 2 significant digits because of the 6,400, so they're going to say 890, just for the record. But we can write the whole thing down. Okay, question. What would happen if we had a city that was in the northern hemisphere and we had a city that was in the southern hemisphere. That was supposed to be an S. So one had a north, one had a south latitude. How would we find this angle right here? Okay, if this is the distance above 0 and this is the distance below 0, we would have to add the angles together, wouldn't we? So in a case where the cities are on the same side of the equator, both north or both south, we would subtract to find the central angle to use in our formula. In a situation where one is north and one is south, we would add the angles to find the angle for our formula. Okay, give those problems a try and ask questions as needed.